Hello, my dear students. Let us take one more example on a simply supported beam to find the slope and deflection. A beam AB of span 8 meters is simply supported at the end. Is a uniformly distributed load of 30 kN per meter over its entire length and a concentrated load of 60 kN at 3 meters from the support A. Find the maximum deflection in the beam and the location where the deflection occurs. So here it's given E is equal to 200 into 10 raised to 6 kilonewton per meter square and I is equal to 80 into 10 raised to minus 4 meter 4. Okay, so the length of the span of the beam is 8 meters. I value is this value 80 into 10 raised to minus 4 meter 4 and E value is 200 into 10 raised to 6 kilonewton per meter square. So this is a simply supported beam subjected to 1 point load of 60 kilonewton and UDL of 30 kilonewton per meter. So it is asked to find the maximum deflection in the beam and the location where the deflection occurs. Okay. First what we have to do, we have to calculate the reactions. Once the reactions are calculated, you have to write the bending equation, moment equation, and then you have to integrate that. Once if you integrate that equation, first equation you get, that is slope equation, and one more time if you integrate, you get the deflection equation. Okay, then to find the maximum deflection, we don't know where it is in between maybe C and B. So for that you have to use the slope deflection equation and find what is X. Once if you get X, you can substitute in the deflection equation and find what is the maximum deflection. So let us calculate first the reactions, that is take vertical forces equal to 0, that is sigma V equal to 0, that is upward force is positive, downward forces are negative. So RA plus RB equal to minus or RA plus RB minus 60 minus 30 into full length, that is 8. That is RA plus RB equal to 60 plus 30 to 8, that is equal to 300 kilonewton. Then you take moment about A or B. I'll take moment about A, sigma MA equal to 0. So what equation you will get? Minus RB into 8 plus 30 into 8 into 8 divided by 2, that is 4, minus 60 into 3. So if you equal to 0, so 8 RB is equal to 60 into 3 plus 30 into 8 into 4. So you get 1140. So RB is equal to 1140 divided by 8, that is 2.5 kilonewton. So we have RA plus RB is equal to 300 kilonewton. So RA is equal to 300 minus RB, that is 300 minus 142.5, that is equal to 157.5 kilonewton. So RA is equal to 157.5 kilonewton and RB is equal to 142.5 kilonewton. Once if you find the reaction, next step is to write the bending equation. For that you have to use Macauley's method and consider any section XX which is at a distance of X from the end A. Okay, so now let us consider this section is here at XX. So what you will write? RA into X. RA is 157.5 into X. So this is bending equation. So MX equal to whatever the equation you get, that have to write, that is equal to EI into d square y by dx square. So first is RA into X, next is minus, because it is downward direction. Here 30 is here only, so you can write the equation here till here, that is 30 into X into X by 2, because it is UDL. So 30 into X by 2. So it is 30x square by 2. You have to write now this division here only because the section is here. So we have considered two loads at this point only. Okay. In the previous problem, how it was, section was considered here and only RA was there. There were no loads. So okay. But here UDL is there. So section is here means you have to consider both RA into X and also this 30 into X. That comes under this part of the section. Next section is where it is here, okay, somewhere here. So what is that? Now RA into X minus 30 into X by 2 minus 60 into this point. X section is here. So I want this distance 60 into X minus 3. Okay. So this is the now equation, bending equation, and let this 1. And now integrate this. So what you will get? EI into dy divided by dx. Here y is not there, just EI into dy by dx. Okay. So what you will get? This here. This is not there. Okay. EI into dy divided by dx, that is equal to 1. Integrate this equation. So 157.5 x integration of x is x square by 2 minus this 30 into x square. Integration is x cube by 3. So x cube divided by here 5x cube, because 30 into x cube divided by 2 into 3, 6. 30 divided by 6 is 5. So 5x cube plus C1. You have to add here minus. Next term is this one. That is again consider this as a one term. So integration of x minus 3 is x minus 3 square divided by 2. So 60 divided by 2 is 30. So this equation is slope equation. Again integrate this, you get deflection equation. That is EI into y. Integration of dy by dx is y. That is equal to here 157.5 divided by 2 into here x cube by 3. So 2 into 3, 6. Okay, then here x4 divided by 4. So 5x2 raised to 4 divided by 4 plus c1 into x plus c2 minus this x minus 3, 3 whole cube divided by 3. So 30 divided by 3 is 10. So this is deflection equation. So equation 2 is slope equation. Equation 3 is deflection equation. Once if you get that equation, next step is you have to calculate at two supports, what is x and what is y. So first consider at A, that point x is equal to 0. Here x is equal to 0 and deflection at A is also 0. So once if you substitute in this equation, you get C2 equal to 0. All the term, if you substitute x is equal to 0 and here y is equal to 0, you get everything 0 except this C2. So C2 equal to 0. Next step, what you have to consider? X at the other end. So what is that? X is here at this point, that is x is 8 and deflection that point is 0 only, because deflection is 0 at the supports. So once if you substitute in this equation, what you will get? This term is equal to 0 because y equal to 0. So substitute x value is 8. You get what is C1 value. So C1 is 883.75. Once if you get C1 value, you can write in this equation. Equation 2 and equation 3. Equation 2, if you substitute here C1 value, it is 883.75. So EI dy by dx is equal to 157.5 x square by 2 minus 5x cube plus minus 883.75. Then minus 30 into x minus 3 whole square. This is slope equation. Then substitute that C1 and C2 in this equation. So you get EIY equal to 157.5 x cube divided by 6 here minus 5x raised to 4 divided by 4 plus C1 into x, C1 is 883.75x, plus C2, C2 is 0, minus 10 into x minus 3 whole cube. This is deflection equation. After that, you have to calculate what is the maximum deflection and its location. To find the maximum deflection, first you have to consider the location where it occurs. So for that you have to use the slope equation. So take the slope equation and equate it, that equation equal to 0. Okay, where there is a maximum deflection, slope at that point is 0. So if you consider that slope equation, this equation ei dy by dx is equal to this equation. So here dy by dx is equal to 0 slope. Okay, that is equal to 0. So this whole term becomes 0, and that equation here, only this part remains here. When you substitute that, not substitute, you only one unknown, calculate x, so you will get x is equal to 3.92. To solve this, you have to use trial and error method. Means you have to substitute different values and find both LHS and RHS. It should be equal to 0. It should be same. Then you take that value. So here we will get x is equal to 3.92. Once if you get 3.92, then you can find what is maximum deflection. So use the deflection equation. This equation, substitute x is equal to 3.92. So in this equation, EI y maximum, that is equal to 157.5 into 3.92 whole cube divided by 6 minus next 5x cube divided by 4, that is this equation, then 883.75x, that is this, and then 10 into x minus 3 whole cube. So simplify this, you get y maximum is equal to 1.366 mm. Okay, so like this you can calculate what is maximum deflection. I hope all of you understood. Main thing you have to see here, first find the reactions. Okay, then take the section. Section is always at a distance of x from A. So then write the bending equation. So that bending equation is nothing but mx. So that is equal to ei into d square y by dx square. So write the whole bending equation and then integrate that. Once if you integrate that, you get one equation, that is slope equation. Again if you integrate that equation, you called it as a deflection equation. Once if you get slope and deflection equation, you have to calculate the deflection or slope. I mean, to get the slope equation, you have to take x at 2 points, at A and at B. So for that, x at A is 0. At that point, deflection also 0, because deflection is always 0 at the support. Similarly, next point x is at B. So that whole length you have to consider, and deflection that time also 0. Once if you get substitute this value in the deflection equation, you get what is C1 and C2 value. Once if you get that, you can write in the slope equation and deflection equation. Consider it as a standard slope equation and deflection equation. Then find the deflection at particular points wherever it is asked. If asked to find the maximum deflection, then you have to locate where that deflection occurs. For that, you have to use the slope equation. Slope at where the deflection is maximum, there will slope is 0 at that point. So you have to equate that slope ei dy by dx equal to 0 and equate to that equation, you get x value. Once if you get x value, you can find what is y maximum. Okay, if it is asked at particular points, directly you can take what is y value and we can find what is the deflection. I hope all of you understood. Thank you.